Alright, unit 2.8 is broken into two parts because first we need to learn what the properties of equalities are and create our reference sheet, and then we need to figure out how to apply those properties of equality to prove our algebraic stuff, right? So first we need to figure out what the properties of equalities are and how they work. Right, properties of equality, right, how the balance works. Alright, so the property we're starting with is the addition property, and we're using if-then statements, which makes sense because we just learned all about if-then statements, right? So if A equals B, right, if there's an equation and the left side is equal to the right side, right, then A plus C equals B plus C. Right? What this means is that as long as you start out with an equation that's equal on both sides, that you can add something to both sides without changing anything. Right? So for example, if you have 3 plus 2 equals 5, they're equal on both sides. Right? I can add 3 to both sides and it changes nothing. Right? 3 plus 2 equals 5 plus 3, which is 8. It's still equal. I can add something to both sides and it changes nothing because 3 plus 2 is 8. So 8 is still equal to 8. Right? Does that make sense? Alright, and then the next one is subtraction property, which is basically the same thing but with subtraction instead of addition, right? So if A equals B, if you start with an equation meaning equal on both sides, that's what equation means, equal on both sides. If you start with an equation, then A minus C is equal to B minus C. Right? You can subtract the same thing from both sides and still keep it balanced. Alright, multiplication property, same thing. If you have an equation, then A times C equals B times C. You can multiply both sides and it still stays equal. Right? And I probably shouldn't use the X for my multiplication, but I wanted you to be able to see it. If I use the dot, you might not be able to see it. I could have used the parentheses, A times C equals B times C. That way I didn't have to use the X. I just wanted you to be able to see it, right? So again, you can multiply both sides by the same number and it changes nothing, right? So if you have 6 equals 4 plus 3, if you multiply both sides by 3, you still get 18 equals 4 plus 7, 3. That's not right. Why is that wrong? Oh, because 4 plus 3 is not 6. Okay. 4 plus 2, my apologies. Right, 18, 4 plus 2 is 8. 8 times 3 is still not right. 4 plus 2 is 6. Wow, I have walked all over this problem, haven't I? 6 times 3 is 18. So you still get 18. But you can multiply both sides by the same number and it changes nothing. As long as you do your basic math correctly, apparently. I guess I need to wake up. Alright, division property, same thing. If you start with an equation, right, if the left side equals the right side, then you can divide both sides. A divided by C is equal to B divided by C. You can divide both sides by the same thing and it still changes nothing. Right? So if you have 8 equals 8 and you divide both sides by 2, you're still left with 4 equals 4. You're still left with an equal equation. It's equal on the left and equal on the right because you're keeping things balanced, right? That's the property of equality. Keep things balanced. All right, distributive property, to distribute, to share out, means if you have something outside the parentheses, you can share it inside the parentheses, right, by multiplying, right? You could do A times B plus A times C, right? You're just distributing it, A times B and A times C. You're distributing the A. You're sharing it. I have an A. I'm sharing it with B by multiplying. I'm sharing it with C by multiplying, right? So if you do that, A times B is AB, and A times C is AC. So all I did was distribute the A, which was outside the parentheses, in order to get rid of the parentheses. But I still kept it fair. I shared it equally, right? Substitution property. If A equals B, then A may be substituted, substitution, right, to replace. A may be replaced or substituted by B in any expression or equation. So if you have 3 plus A equals 12, and they tell you that A equals 6, then you can put 3 plus 6. I can replace the A equals 12. Well, that's not going to work, is it? Why do I do this to myself? Let's try that again. If you have 3 plus A equals 12, and they tell you that A equals 9, then you can replace the A with 9. 3 plus 9 equals 12. And that is true. 12 equals 12. Right? So if you know the value of A, you can replace A. That's substitution property. All right, next up is reflexive property. And it's what it sounds like. It's the reflection, reflexive, reflection. Right, for any real number A, right, A equals A. All right, so 5 is always going to be equal to 5. They are reflexive. Five is 5. Symmetrical property, now that we know what symmetrical means, right? Balanced, equal on both sides, right? Symmetrical property says that if A equals 5, then 5 equals A. You can literally just flip the equation and it doesn't change anything because they're symmetrical. They're equal. Think about the letter A we talked about, right? If I had the letter A and I flipped it, it's still the letter A. It's reflexive, right? And transitive property, transit. Transit's like bus stops. You stop at stop 1, stop 2, stop 3. Eventually you started at stop 1 and you ended at stop 10. You made a bunch of stops in between, but you still got from 1 to 10, right? So, transitive property says if A equals B and B equals C, right? Transitive property, if A equals B and B equals C, then A equals C. You can skip the B. Does this look familiar? Is this the law of syllogism? Because it is, right? P, Q, Q, R. It's just the law of syllogism, right? So if the center matches like that, then you can cancel it out and skip it and go straight from A to C. Why is this handy? I'll tell you why it's handy. Alright? It's handy because what if you have, I'm going to use this line, but we're going to erase it because this is not part of this. Alright, so what if you have square root of 16 and you want to turn it into something else? Right? What if you don't want to have to deal with the square root? Well, the square root of 16 is 4. But what if you want to break that down even further? Right? 4 is 2 times 2. Right? So if you have the square root of 16, you can skip directly to this if you want to. They are interchangeable. Transitive property says that they're all equal. You can replace any of them with any of them. I know, it's interesting, but that will come in handy the further you get in math, because it's going to give you, you're going to end up with really complicated problems that you can simplify by replacing them with something much easier. All right, so name that property. Write the name of the property that justifies each statement. Name that property. All right, so what we have to do is look at what is occurring, how do we get from here to here, and then name the property that got us there. Right? So one says if k equals 3, then 3 equals k. All right, so what property is that? Symmetrical. Right. Right? They're not identical, but they are equal. If they were identical, then it would be reflexive property. But they're not identical, but they are equal. So we just flipped them. That's reflexive property. I mean symmetrical property. We just flipped them. That's symmetrical property. 2. If 2x equals 14, then x equals 7. So how did we get from here to here? Well, we divided both sides by 2, right? If we divided both sides by 2, that's division property. Three, 10y equals 10y. They're identical. Reflexive, right? They're identical. Reflexive property. Feel free to pause it ahead of me and see if you can get them ahead of me, and that way you can track whether or not you've got this figured out. If negative 5x minus 1 equals negative 11, then negative 5x equals negative 10. So how did we get from here to here? We added 1 to both sides. We added 1 to both sides, right? These canceled, and this became negative 10. If we added 1 to both sides, then that's addition property. In a way, you've been doing these all along. You just didn't realize they had, like, official proper names. All right, 5. If 10a equals 2b and 2b equals c, then 10a equals c. A, B, B, C, P, Q, Q, R, right? Law of syllogism, right? This is called transitive property. Transitive. They're in transit. If it helps you, think about them as bus stops. Transitive property, right? The bus starts in the same place and it ends up here, but it has stops along the way. Right? Transit. Transitive property. Alright, 6. Negative 7 times the group n minus 4 is equal to negative 7n plus 28. How did we get from here to here? We distributed to get rid of the parentheses, right? Negative 7n. Negative 7 times negative 4 is positive 28. We distributed. That's distributive property. All right, 7. If 6y equals 24, then 6y minus 3 equals 24 minus 3. What did we do to get from here to here? It looks like we subtracted 3 from both sides. Right? We're still equal, we're still balanced, but if we subtract 3 from both sides, that's subtraction property. So this is all about figuring out how they did it, how they got from this equation to this equation. If 10x plus w equals 41 and w equals 1, then 10x plus 1 equals 41. So what did we do to get from here to here? We replaced the w with the 1. We substituted, right? Substitution property. All right, pause it and try number 9, and then restart and see if you ended up with what I ended up with. 9 says if 3x equals 2y and 2y equals z, then 3x equals z. Right? P, Q, Q, R. Transitive property. Right? Let's see how this would come in handy. Think for a second, if you had an equation that had an x and a z in it, and then they give you some randomness with an x and a y in it, wouldn't it be handy if you could replace and end up with something that matched your equation so that you could, like, simplify? You can't simplify unless they have the same variable. So wouldn't it be nice if you could switch, mix and match, and figure out what matches your equation so you could simplify? That would be handy. All right, 10, same thing. Pause, think about it, and then see if you get what I get. All right, to get from here to here, it looks like we added 4 to both sides, right? Add 4, add 4. That's addition property. Ask yourself, what did they do? And that's your answer. Same with 11. If negative 2c equals 18, then 18 equals negative 2c. They're equal, but not identical. So symmetrical. Given 3x squared plus 1, if x equals 5, then 3 times 5 squared plus 1. So to get from here to here, it looks like we replaced x with 5. Substitution property. We substituted. Have you ever ordered something online from Walmart and then you go to pick up your order and they're like, yeah, we were out of that, blah, blah, blah. And so we substituted for something else? Substitution property. (13) If m equals negative 2, then 8m equals negative 16. All right, so this one is flipped, but it's asking the same thing. How did we get from here to here? How did we use this to get from here to here to here? Okay, so to get from here to this, to find out what m was, we divided both sides by 8. Division product. And lastly, 14. 5x plus 8x equals 8 times the group 5 plus 8. Again, they have flipped it around. They want you to see that it can be either direction. You still have to figure out the same thing, right? This one has two possible answers, and I'm going to explain to you why. If it was written the other way, then you distributed to get here, right? So distribution property. But they put it backwards to see if you were paying attention, if you could figure out how to go from here to here, right? The problem is, by putting it backwards, they've created a completely separate equation. They've accidentally asked, how do you go from here to here? And that answer is different, right? To go from here to here, we divided both sides by x. We pulled out the x, right? We factored out an x. So we actually factored to get from here to here. So it really depends on how you want to ask the question. In my opinion, they flipped it around to test whether or not you could go from here to here, recognize that it's backwards, which means this is the answer. But because they flipped it around, they confused the issue, and they kind of make you wonder, are they asking about from here to here? Because if they are asking about how do you get from here to here, then we factored. We factored out the common factor, right? They have a common variable, x. You can factor it out, and this is what you end up with. But because of what we're learning, I'm going to assume that this is what they were looking for. Hopefully. All right.